Okay, in this section we're going to go to the actual configuration of the access list on the ASA firewall, and we're going to do that with both object groups and without object groups to see what is the difference in the configuration part, and also to better visualize the enhancements and the flexibility that object groups are adding when configuring access lists. So looking back at the diagram now, as we have the ASA already configured with nameifs, IP addresses, security level, and routing. So this is our inside interface, inside, with a security level of 100. And this is our outside interface, nameif, with security level of 0. So based on those default security levels of 100 and 0, it means that traffic flowing this way from outside to inside, it should be dropped by the ASA firewall by default, based on the security level behavior. So let's go ahead and confirm that to begin with. Like, let's try to go on router 4 in here, and ping will tell it to whatever destination, like router 3 or router 1. We'll try and initiate a session this way, and we'll look in the ASA logs to see that the traffic is being blocked based on the default security levels. So let's go on the on router 4 in here, and if you say show IP route the IGRP, we have a route, for example, for the loopback of router 3 through the ASA firewall. So if we say like ping 10.3.3, if that traffic doesn't work, and if you look on the ASA logs in here and we say show logging, there you go. We see in the ASA logs it says deny inbound ICMP source from the internet interface, which is the outside interface from router 4, and destined to the inside interface to router 3. It's a type 8 code 0, which is the ICMP echo request. So the traffic is being blocked. We can see this as well using the packet tracer function. Now packet tracer, what it does, it simulates a packet going to the ASA, and it's going to tell you, what will the ASA do with the packet, and like, is the ASA gonna drop the packet? Is the ASA gonna allow the packet? If it's gonna allow the packet, is the ASA gonna do any kind of like QoS, any kind of NAT? It's gonna show you what are the access lists being matched by the packet. So exactly as the name of the function says, packet tracer, the ASA is gonna inject one packet as you configure it with a source and destination, and it's gonna show you a detailed output on what will the ASA do if it would receive that packet to begin with. So because my packet comes from the internet, so I'm going to say packet tracer input internet. That's the incoming interface, input internet, and it is going to be a ICMP in my case. Let's say, for example, it's going to be a TCP packet. It's going to be the same thing to simulate a TCP packet. TCP from a source of router 4, for example. Source port number random, doesn't matter, let's say 20,000, and a destination of router 3's loopback. Let's simulate this time a TCP session is going to be dropped as well on, let's say, port 23, which is going to be telnet, and let's say detailed. So I'm telling the ASA, hey, show me what would you do with a packet if you receive it inbound on the internet facing interface, being a TCP packet with this source IP address and source port number, and with this destination IP address and destination port number. And let's go till the end. So initially it says in here, step number 1, phase 1, access list, it says allow, which might seem weird, but this is because like there is no like access list to begin with applied. It says input interface internet, and we don't have any inbound ACLs applied at this point, so it says like allowed. Then it says, and it makes sense because currently we don't have any inbound ACLs applied on the internet interface. So what the ASA does is it cannot drop the packet just because there is no inbound ACL in there. It has to do a raw lookup for the destination to see how would it route the packet. Because with the default behavior, the ASA has to say, okay, so I received this packet inbound on this interface, inbound on that interface, with a security level of 0. Out where would I route the packet? Out on which interface? Outbound there is a security level of 100, and then it's gonna say I cannot do this. I have to drop the packet because the security level functionality doesn't allow me to do that. So the next thing it does, it says route lookup to see, okay, what will be the egress interface? That's going to be the inside. And then in phase 3, it says, do I do any kind of NAT back and forth? We don't have any NAT defined, so no NAT being done. The result is allow per the NAT functionality. And then it's going to be a phase 4, which says access list drop. And it says in here implicit val. Implicit val meaning that the ASA we know doesn't allow traffic by default to flow from the low security level interface out to a high security level interface, which is what I'm trying to do. We could do the same thing from the ASDM. We see the same with the same logs from ASDM. Like for example, if we go, let's go on test array in here and connect to via ASDM to ASA3 and look at the same logs from the ASDM to begin with. So first of all, let's configure the ASA to allow HTTP session, ASDM sessions from server A. We're going to see HTTP from server A 172.16.10.100 on the inside interface. And let's configure a username for connection. Username, let's say CISCO, password CISCO, with a privilege level of 15, which is required for ASDM access. Now let's go on server A, connect to the ASA interface, which is going to be the inside one. Open up ASDM and say CISCO. So first of all, let's look in the logs of the ASA to see the same thing that the ICMP packet was dropped to begin with. We go to the monitoring tab, and then we should go to logging here on the left bottom side. Then we look in the buffer. So we first went to monitoring tab in here, then we went to the logging, and now we're going to go to log buffer. I have not enabled logging in real time. Of course we could do that. I'm just going to go to see in the buffer, say log buffer. ASDM logging is currently disabled. Let's say enable logging. So ASDM logging is disabled. Say OK. Debugging, and let's say view. And let's try and ping again from router 4. And now looking in the ASDM logs in here, let's say refresh. We see in here the ICMP packets being denied. I'm not sure if I can, probably I cannot zoom in for sure. Let's say show details. When you say show details, it's going to show you here on the bottom side. Not really special, except the fact that the syntax of the packet being denied, it says deny inbound ICMP from source interface and source IP address, so nothing special. But we see in here this line which states, or this set of lines which are stating that ICMP traffic from router 4 to router 3 is being denied. We know why by the implicit val. Of course, we could also test, we could also do the packet tracer from the ASDM. So if we go to monitoring, let's go to configuration. Let's see where the packet tracer function is. firewall. I think it should be under the tools somewhere. Tools, packet tracer. There we go. So let's do the same thing. I'm going to say source IP address is going to be router 4, 136.1.47.4. Destination IP address router 3, 10.3.3.3. And source port, whatever, something random, doesn't matter. Let's say 20,000, as I said before. Destination port 23 or 22 SSH, let's say. And packet comes inbound on the internet facing interface. So we do the same thing as on the CLI. What is the input interface? Then what is the packet type? TCP, UDP, ICMP, or IP packet? I said TCP, and then it's gonna be sourced from router 4, and with that source port number, and destined to router 3 with that destination port number. And we say start. And that's going to show the phases, the same thing, the same steps we saw in the CLI. So initially it said step number 1, it was ACL lookup to see if I have any kind of inbound ACL applied on the outside interface, and I don't. Then it did a router lookup to see, okay, what is the egress interface, in order to see if the security level functionality applies and I should drop or allow the packet. And then it did a NAT lookup to see if that has to happen or not. And then ACL lookup, which means now that I know the packet flows from a low security level interface to a high security level interface, because I don't have any explicit ACLs allowing that, I'm going to drop the packet. And this is what gets as an end result in here. Information says ACL drop, flows denied by configured rule. Actually, we know it's denied by the implicit security level functionality of the ASA. So next, let's do the following. Looking back at the diagram, we're going to allow traffic to flow, let's say sourced from this subnet. Source is going to be VLAN 47. We want traffic sourced from VLAN 47 and destined to either VLAN 94, so destined to VLAN 94 or VLAN 92. We want traffic with that source and any of those two destinations to be allowed. If it's going to be, let's say, SSH traffic or telnet traffic, or let's say, so SSH, telnet, and what else could we add in here? Let's say HTTP as well, HTTP. So all of them are TCP applications. So initially, and we want this traffic to be allowed by the ASA to flow in this direction, which currently is not being allowed by the security levels. So we're going to configure that ACL and then apply it inbound. We're going to apply the ACL inbound on this ASA interface, because that's our problem. The ASA doesn't allow that traffic to flow back and forward because of the default security level functionality. So first we're going to do that by using just regular access lists, no object groups, and then we're going to convert the configuration using object groups to see how does the ACL look like, and to better visualize the enhancement and the scalability object groups are adding to ACL configurations. So we're going to do that to begin with from the CLI, then we're going to look in the SDM. Let's go on ASA3. So we want to say access list, let's say access list. I'm going to name this the internet in, because it's going to be applied on the internet interface inbound. And we want to allow permit TCP traffic from source VLAN 47 to source VLAN 94, 172.16.10.0. If it's the destination port is going to be SSH to begin with, or if it's going to be telnet, or if it's going to be HTTP, which is port 80. And we have to do the same thing for the other destination, which is going to be for VLAN 92. The same traffic we want to allow it from the same source. So we have to actually copy this ACL one more time and replace just the destination IP, the destination network, So let's open up a text file. Let's say new. Let's paste this ACL in here. And then we just want to change the destination from VLAN 94 to VLAN 92, which is 172.16.10. So let's go in the notepad and say to 10.10.10. So 3 more lines in there. So the step number 1 was achieved, configure the access list, and step number 2, we have to apply it inbound on the internet interface access group, because that's our problem. Access group internet in, and then you say the interface of internet. So at this point, all traffic coming inbound on this interface is going to be, doesn't matter where it goes out to, is going to be controlled by this access list now. So I should be able at this point, from this subnet, so with a source of that and with a destination of either VLAN 94 or VLAN 92, I should be able to send traffic through the ASA now in this direction, as long as it's SSH, TCP traffic, as long as it's SSH, Telnet, or HTTP. Let's confirm that. Let's go on router 4 and let's Telnet to, let's say, to router 1's addresses of those two VLANs 92 and 94. So Telnet, let's say 172.16.10.1. That's router 1's IP address. It says connection was successful, but there was no password set on VTI lines. Let's go on router 1 and put some passwords on the VTI lines. So we actually connect successfully. Line VTI 04, let's say password CISCO. So let's go back on router 4, Telnet again, and CISCO. And if we say who, then we see that I was connected from router 4's address. If we go on the ASA tree, first of all, looking in the connection table, we should see that connection in the ASA table. There we go. TCP traffic from the internet with a source of router 4 and source random port number, destined, the egress interface being the inside interface of the ASA, destined to router 1 on a telnet port, and it is up, and we have inbound and outbound traffic back and forth, those being the flags. If you say detail, show connection detail, it's going to show in there what the flags means. So the U flag, which should be, there we go. The U flag means that the connection is up, which means the tree handshake was established. Then if you look at IA flags, at I and O flags, the I flag says we have inbound data. The O flag says we have outbound data, which means traffic flowing both ways, because that's a TCP session. And the B flag says initial send from outside, which is a bit misleading. Well, actually what this means is that a session was received by the ASA on it. What this means is that traffic was flowing from a low security level interface to a high security level interface. That's what the outside actually means. So you're going to see the B flag whenever the ASA is going to allow a session, and the direction of the session, how it was initiated, as it was my case, because the session was initiated this way, and it was flowing from a low security level interface of a 0 to 1 of 100, so low to high. That means the B flag is going to be set in there. So this has nothing to do with the name if of outside in there. It just means that the initial SYN packet was received inbound on a low security level interface, and packet was routed outbound on a high security level interface. So you see the telnet session worked. Of course, also HTTP should work. If we go to router 4, say exit, I'm not sure if HTTP and SSH are enabled on router 1. Let's say show IP SSH to see if SSH is enabled, and it is disabled. So let's first create RSA key, a pair of RSA keys, and then enable SSH. Crypto key generate RSA general keys modulus 124. In the older codes, you have to specify the domain name. In the newer codes, you don't have to do that. So IP domain name inelab.local. So in the older codes, you had to specify the domain name because in the private public RSA key being generated, the domain name was in there as well as the name of the key. If you say show crypto key my pub key RSA, so this means show me the from the crypto key pair my public key of type RSA, because the private key is by default non-exportable. So we say in there, show me my public key of all RSA private public key pairs. And there we go. The name is router name domain name. So for that reason, in the older codes, you have to specify a domain name before being able to create a RSA key pair. If you say now show IP SSH, SSH should be enabled by default. There we go. Is version 199, which it's not version 2. Let's say IP SSH version 2. And now let's go and SSH from router 4 to router 1 to see that SSH is also allowed. But of course, SSH requires username password authentication. So let's go on router 1 and say username CISCO privilege 15, password CISCO, and go on the VTN lines and say login local, which means I want to authenticate using a username password from the local username database now. So all VTI access is going to be now authenticated using local username password from the local database. Let's go on router 4, say set exit. So SSH, and then we say the username minus L Cisco, and then we SSH to, and let's SSH to VLAN 92 IP address of router 1. So 172.16.1.1. And Cisco the password. And if we say who, I am likewise connected from router 4. If we go on ASA tree and we say show connection detail, we should likewise see now the SSH session being in the state table of the firewall. So traffic from the internet from router 4, random source port number, packet was routed out on the inside interface of the ASA, descent to router 1 and SSH traffic. And likewise, we see the same flags. The session is up. We have traffic flowing both ways, inbound, outbound, and the B flag, which means session was initiated from a low security level interface and routed out on a high security level interface. Now, so of course, if you say show access list, so the verification is going to be show access list to see the ACLs being configured. Show access list. This is going to show you, of course, those 6 lines we have configured. And of course, we'll also see hit counts on the specific ACL entries we've matched with our traffic. So this was for Telnet, 2 counts, and this was for SSH, should be 1 hit count for SSH. And that is, there we go. This line says hit count 1, which is, this is for the SSH traffic, because we initiated 2 Telnet sessions and 1 SSH session. If we do packet tracer again, packet tracer input, before we do that, so we said show access is to verify the ACL, and that's going to show the, let's say, the detailed version of the ACL. If you say show run access list, this shows you how the ACL was actually configured. It's going to be the same thing because we have not used object groups. And if you say show run access group, this is going to show you on which interface do we have any ACLs applied, and we have only one applied inbound on the internet interface. So let's do packet tracer again, and we're gonna simulate now one packet which one session which is gonna be allowed by the ACL. Input on the internet, let's say TCP, likewise from router 4, source random port number destined to router 1 on any of its VLAN 92 or 94 addresses, and let's say port 80. Let's also make sure that HTTP is being allowed, and let's say detailed. So likewise, initially it says now, so phase 1 type access list, and now it's gonna say, do I have any? It's gonna do the same thing, the same phase 1 in there, and it says result allow input interface internet. We're not sure what is the egress interface yet, so we do route lookup. We find the egress interface to be inside, so we go low to high, which means we need an access list to allow that traffic to flow. And then phase 3 access list says result allow, and it's going to show you exactly on which ACL I matched. That's my ACL applied inbound on internet interface, and also on which ACL entry I matched with this traffic flow. So now traffic is being allowed as expected by the inbound ACL. We do know NATs, so phase 4 NAT is going to be allowed. Phase 5 IP option inspections, we cannot simulate with packet tracer of IP options, so it's going to be allowed. Phase 6 is NAT of type per session, because we can have per session NAT limitations on how many NAT sessions can be allowed for on a specific NAT statement. Again, IP options, and then flow creation and allow. So traffic is being allowed as expected by the ASA. And of course, we can also see that from the ASDM. If we go back again to tools, packet tracer, we simulate the same traffic we did before we say start. This time it should work. It's flowing through all of those phases. It says dropped. Okay, clearly it is a drop because destination is not allowed by my access list. So let's put in there a destination which matches my ACL configuration. Let's put it under the destination one of the addresses of router 1 in those two VLANs, 172.16.10.1. So now source is from the proper VLAN, from router 4's VLAN. Destination is on the proper VLAN, and also traffic is the service is allowed SSH. So this time we should have a allow if we say start again. It still says ACL flow is denied by configure rule. Let's say clear and start fresh, because let's say clear. Let's also refresh ASA configuration. Let's say refresh on ASDM to reread again the configuration, because we've done changes on the CLI. And let's say tools, packet tracer, and say again interface. Inbound interface is going to be the internet. Source address from router 4, whatever random port number source. Then destination is going to be one of the allowed VLANs per my ACL 10.1, and let's say SSH, and let's say start. Destination port cannot be empty. I said 22 in there. Let's say SSH to see if it finds it. SSH, and let's say start. So it was just a glitch on the GUI, because I think I've done the refresh initially. So as you can see, packet made it through all of the ASA steps, the final result being flow creation, which means packet is going to be allowed, it's going to be okay. If you look at the last step in there, it says in here that the packet is allowed as expected. So packet is allowed in there. If you go on the SDM, of course, how we would have configured this on the SDM, you go under configuration. So you go under configuration tab, and then you go under the firewall functionality, and then you go under AA, not AA rules. You go then under ACL manager in there. So if you go under the ACL manager, it's going to show you which access lists have been configured. We have only one now. So we have in here the name of the ACL and those 6 lines we have configured in that ACL. That's where you define the access list. So you would say add and just add an access list, or of course you could go under the, let's say, access rules, and in this specific place is going to show you which ACL is applied on which interface. It says the inbound on the internet interface, we have 6 rules because it says 6 incoming rules. So this means that on the internet interface we have an ACL applied with those 6 rules, and that's as expected because that's what we have configured in there. Okay, on the inside interface, so you're going to see in here all of the interfaces with any ACLs applied in or out. So we see in here, first of all, the inside interface, which they state we have the implicit incoming rule because we know there is no ACL applied inbound on the inside interface as expected. And then we have the internet interface, the other interface of the ASA. And in here we have 6 incoming rules configured because we have 1 ACL applied inbound. And the last step of this is going to be the global ACL, which we have no global ACL applied, which means it's a permit any in there by default, the global ACL, if it's not configured.